Inverse functions. An inverse is something that undoes an operation in mathematics. So if you think about your basic four operations, addition and subtraction, those are inverses of each other. So if I take a number and add 3 to it, and then I were to subtract 3 from it, I would get the same number back. As well as multiplication and division are inverses of each other. Well, let's take a function, f of x equals 2x plus 3. Here we have a linear function, and we're asking ourselves, well, what would undo this linear function? So if I did something to x, what could I do, or what would I do to undo what I've done to it? So remember, f of x is simply a fancy way of saying y equals 2x plus 3. Our first step, and we'll write these off to the side, is to replace your x's and your y's. And the y's with x's. So our new equation is going to be x equals 2y plus 3. The second thing we're going to do is go ahead and solve for y. And we're going to do this just like we've done in all of our other equations. We want to get y by itself. So we've multiplied it by 2 and then added 3. To undo that, we're going to subtract 3 from both sides. So we get x minus 3 equals 2y. And then we're going to divide by 2. So we end up with x minus 3 divided by 2 equals y. And this is our f inverse function. And we can write that in notation form, f to the negative first of x, or leave it as y inverse. But really what we're looking at is this x minus 3. So let's say I gave you a number 3 for x. So if x equaled 3 and I found f of 3, plugging it in, I would get 2 times 3 plus 3. 2 times 3 plus 3 gives me 9. If I found the f inverse of 9, so if I took 9 and plugged it into my inverse function, I would have 9 minus 3 divided by 2. So 9 minus 3 gives us 6 divided by 2 is 3. Notice our answer is what we started with. If you think about your f and f inverse in this process, we're really looking at a composite function. To where, say, we had our f of x function as 2x plus 3, and our g of x function was x minus 3. So let's go ahead and look at those two functions in that form. Let's look at f of x equals 2x plus 3, and let's look at a g of x equal to x minus 3 over 2. Remembering, we just found that this was the inverse of this. What happens if we find f of g of x and g of f of x? Notice my two different notations. Well, I'm taking my g function, plugging it into f. So I have 2 times x minus 3 over 2 plus 3. 2 times anything divided by 2, those 2's are going to cancel, so I end up with x minus 3 plus 3. Negative 3 and positive 3 are going to cancel, so we end up with x. Looking at g of f of x, I'm taking my f function now and plugging it into g. So I'm looking at 2x plus 3 minus 3 divided by 2. In this case, my 3's cancel at this point. So I'm left with 2x divided by 2, which equals x. Notice my final answer in both of them are x. And that's a great way to check your work when you find the inverse, is to go ahead and find f of x, find your inverse, and then find the composite function of each of them. They both should come up with x as your final answer. Now in example 2, we're going to take our f function and we're going to change it slightly. We're still going to have a fairly easy function, but let's make it a little more complicated. Let's say we have x plus 3 divided by 2. To find our inverse, remember we're going to replace our f of x with y, x plus 3 divided by 2. Change your x's and your y's. X equals y plus 3 over 2. Now we're going to solve for y. So we've added 3 and then we divided it by 2. To get y by itself, we're going to get rid of the 2, so we're going to multiply both sides by 2. And then we're going to subtract 3. So our inverse is 2x minus 3. And there's our final answer. That is your f inverse of x. Now in example 3, let's go ahead and look at a quadratic function. Quadratics work just like our linear function did. So let's take f of x equals x squared minus 5. Replace your f of x with y equals x squared minus 5. Replace your x's and your y's. So x equals y squared minus 5. Solving for y, we're going to add 5 to both sides. So x plus 5 equals y squared. Now we have to think, what undoes the square? And from Algebra 1, you should know that the square root undoes a square. And those are inverses of each other. So we have the square root of x plus 5. But remember, when we take the square root of a number, we can have the positive or the negative of that number as our answer. So we have plus or minus the square root of x plus 5. And that's your f inverse as well for this function. Now let's go ahead and take a look at a radical as our function. And let's say this is g of x equals the square root of x minus 3 plus 2. Now, notice we have a negative 3 under the radical and a 2 on the outside of the radical. Same process, y equals the square root of x minus 3 plus 2. Replace your x and your y with each other. So x equals the square root of y minus 3 plus 2. Solving for y, we have to get rid of that 2 first. So we're going to subtract 2 from both sides. So we have x minus 2 equals the square root of y minus 3. Now what undoes the square root? On our last example, it was squaring. So we're going to take x minus 2 and we're going to square both sides. And then we're going to go ahead and add 3 to both sides. So we have x minus 2 squared plus 3 equals y. And at this point we can go ahead and leave it in that form. Later on, we're going to go ahead and square this out and simplify by combining like terms once we get into our quadratic section. And this was example 4. And that should conclude our operations, our inverse operations.